Lesson 86, volumes of pyramids and cones. So we know how to compute the volumes of cylinders and prisms, and so we're going to use that information to help us figure out how to do cones and pyramids. So just a quick review of how to find the volume of a cylinder. It's the base area times the height, and the base area happens to be a circle. So this base that we're talking about is pi times radius squared times the height of the cylinder. And this is the height of the cylinder. It goes from one base to the other. And so if we're going to do that, then we're going to take pi times radius squared, so 4 squared, times 9. And so we would do 4 squared times 9 times pi on our calculator, and we would get an answer, and it would be in centimeters cubed. How to find the volume of a prism. Rectangular prism is take the area of its base. So again, I'm going to use this as the base right here. And then I'm going to multiply that by the height of the figure. So the area of this base is a length times width, or base times height, whichever you want to think of that as, times the height of the figure. And so we have 6 times 8 times 10. And 6 times 8 is 48, times 10 is 480 inches cubed. And so those are both volumes. Again, they have to be inches cubed because we're doing 3-dimensional. And this one I would just put in my calculator, this first one, and figure out how many centimeters cubed. So if you look at a diameter of a cone and a cylinder, if you're looking at the same cylinder, their diameters are equal and their heights are equal, but the parts can't be equal because, of course, the cone fits inside of the cylinder. So this method shown here is that the volume of 3 cones equals the volume of 1 cylinder. So basically, if you filled up 3 cones with sand and you poured them into the cylinder that was the same diameter and height, you would be able to fit 3 of them. So then, the volume of a cone is 1/3 of the volume of the cylinder. If it takes 3 to fit in, then it has to be 1/3. So anytime we have cones, all we need to do is take 1/3 of the area, the volume of the cylinder. And so there's that formula, 1/3 base area times height. So here's this problem. And we have Aiden built 2 cones out of sand on the beach. The diameter of the smaller cone is 6 inches. And the height is 5 inches, so diameter is 6, so the radius is 3. They gave us radius here. And the cone is 12 inches wide, the larger one, so the radius is 6, and its height is 10. And so we can find the volume of these 2 cones, because it says how many cubic inches of sand did Aiden use for each cone. So we need the volume of the smaller, and we need the volume of the larger. And so this is 1/3. And again, it's base area. Base area is pi times radius squared times the height of the figure. And then we're going to do the same thing for the second cone, the larger cone. And so we're going to do 1/3 times pi times radius, 6 squared, times the height of the figure, which is 10. And I'm going to actually do some canceling here, so I'm going to rewrite these as 3 times 3 and 6 times 6. And the reason I did that is really the 1/3, I can do some canceling then nicely because 3 cancels with this 3 over here. And so really I just have 15 pi. And on the second one, I'm going to cancel this 3 with this 6. That's going to give me 2. And so I really have 2 times 6 is 12 times 10 is 120 pi. And notice it says express pi as pi, and so that's the step I'm at. And if it didn't say that, I would multiply 15 times pi and get an answer in 120 times pi. But what we want to look at here is how many times greater is the volume of the larger cone than the volume of the smaller cone. So in other words, how much bigger, or what do we have to times the smaller one by to get the larger one? And of course the pi's here then kind of cancel out, so we don't need to worry about the pi part of this. So we're really looking at the number, because we're looking for ratios, a ratio here. And so if you take 120 and you divide it by 15, you get 8. And so this bottom cone, or the larger cone, is 8 times bigger. Than the smaller cone. Okay, and this is, again, this is the reason why we leave pi as pi a lot of times, because then we can look at these without the pi by canceling them off, basically, and look at just what the ratio of the numbers is. If they wanted us to write the ratio of the smaller to the larger, we would write 15 pi over 120 pi, which is just 1/8. So again, we can do some canceling of the pi's, canceling of the 120 and 15. And so without multiplying out that pi, there's a lot of different things we can do. We can look at the ratio. We can look at how many times more something is, or how many times bigger. So volumes of prisms and pyramids are related the same way. If you take the volume of a prism and that has the same base and same height, 3 pyramids fit into the prism. So we're going to use the same basic formula, only we need to do the base area of this is a square. So the base area times the height, and we're going to do 1/3 of that. And so the base area here is 90 times 90. The height is 50, and we have 1/3 of that. And again, we can do some nice canceling, because these are like over 1, all of them. And so I'm going to take 3 and put it into the 90. That's 30. And so 30 times 90 times 50. And so that's 3 times 9 is 27 times 5 is 135, and then we have the 3 zeros. So 135,000 centimeters is the volume of that cube. Centimeters cubed. Don't forget the cubed on the labels there. Triangular pyramid. It's still basically the same problem, because we still have the volume equaling 1/3 the base area times the height. Only this time the base area is a triangle, and they actually show you what that triangle looks like. They show you what that bottom triangle looks like. They just pulled it off so you could see what it is. And so we have to do a little bit more work here, because in order to do this, we need 1/3 times the base times the height divided by 2, which is the area of any triangle, times this h, that's the height. And this h they're talking about here is the height here. This h here is the height right there. And so they actually tell you that the height they tell you the height is 36 times the square root of 3 units. I took a minute because I couldn't figure out what they did here. They took this 12 times 6 times square root of 3, and if you do 12 times 6 square root of 3, you get 36 square root of 3 to find that area of that triangle. But they should have divided it by 2. So I think they made a mistake here, because it really should be 18 square root of 3. Oh no, because I made a mistake. Here, 12 times 6 is not 36. 12 times 6 is 72. and then they divided it by 2. So it is 36 square root of 3. So they already figured that out for you, so you didn't have to. And so they've already basically, this base area times height right here, or base times height divided by 2, is the 36 square root of 3 that you have there. So then we have that times 10, and we have 1/3 of that. And if it helps you put these over 1, I'm going to do some canceling now. 3 goes into 36 12 times. And so we have 12 times 10, because those are both outside the square root. Square root of 3. And then what units? This is given in units. Doesn't have any other units given. No centimeters, no inches. So this is units cubed. So 120 times the square root of 3 units cubed.